Hi, hello, how are you? I hope you all safe at home. So welcome back to mathematics class. Dear students, today we are discussing about problems from logarithmic inequalities. Are you ready for the first question? So coming to the first question, solve log of 9 power x minus 1 plus 7 to the base 2 is equals to 2 plus log of 3 to the power of x minus 1 plus 1 to the base 2. So coming to the solution, see left side which is with logarithmic base 2. And even right side also one of the term with base 2. Now there is another term which is 2. Now can we express 2 also into logarithmic base 2? Can we? Yes. How can we write this? So this is the important step in this problem. So let me want to write this is as log 4 to the base 2. Isn't it, ma? So what is the log 4 to the base 2? Actually log 4 I can write it as 2 square. Hence this is 2 into log 2 to the base 2. Anyhow which is 1. So 2 into 1 which is 2. So why? Because as I already informed you that the simplification of logarithmic inequalities are depending on the base. So if base is clear, if base is same, then furtherly we can simplify. So that point here 2 I want to express as log 4 to the base 2. Okay. Now look at me, ma. So this is as usual 9 to the power of x minus 1 plus 7 to the base 2 which is equals to. Now both are having the same base which is 2. And these are like log x plus log y. So how can we write it? This is log x into y. That is 4 into 3 to the power of x minus 1 plus 1. Now finally both are expressed into single logarithm. Now while comparison, because is equals to no, since because of logarithmic base is same, hence these numbers are also same. This is I can write it as 9 to the power of x plus 1 9 to the power of x minus 1 plus 7 is equals to 4 into 3 to the power of x minus 1 plus 1. Okay. So what is the next step? Now here there is a 3 to the power of x minus 1, whereas here 9 to the power of x minus 1. So then 9 to the power of x minus 1, actually can I write it this as 3 square whole to the power of x minus 1 plus 7 is equals to, this is as it is, ma, 4 into 3 to the power of x minus 1 plus 1. And this is, actually this is like a to the power of m whole to the power of n, a to the power of mn. So this is, I want to rewrite as like this, 3 to the power of x minus 1 entirely whole square. Isn't it? Just I want to change this m and m. No problem. M into n, mn, even n into m also mn only. So plus 7. And if I bring this side, minus 4 into, this is 3 to the power of x minus 1 and minus 4 which is equals to 0. Right? Now clearly there is a term 3 to the power of x minus 1. So let it be, assume some y. So let y is equals to 3 to the power of x minus 1. Hence this is, can write it as y square. Okay, ma. And this is 4 into, no, this is minus 4y, and 7 minus 4 which is plus 3 is equals to 0. So clearly we got a quadratic equation. So we need to factorize. The factors are minus 4 and plus 1. Is this, just check it, ma. No, minus 3 and better you go with minus 3 and minus 1. Minus 3 and minus 1. Yes, I think now it is correct. So since both are equal to 0, we can equate them. Hence, first one is 3 and second one is 1 after equating. But you know y means 3 to the power of x minus 1 is equals to 3, comma 3 to the power of x minus 1 is equals to 1. Now this 3 is nothing but power 1. No? So clearly I can mention that x minus 1 is equals to 1. And from this, if I send minus 1 that side, 1 plus 1 which is 2. And similarly here, 3 to the power of x minus 1 is equals to 1 I can express as base 3 to the power of 0. Okay. Now on equating, x minus 1 is equals to 0. So from this we got it x is equals to 1. So finally the values of x are x is equals to 1, comma 2. For these values of x, when it is 1 and 2, the given equation is true. So in the entire problem, the important step is, this is the important step. So this is the technique. So we need to convert into a logarithm with the same base as 2. So after this, this is x plus y, log x plus log y, it became log xy. Now both sides with the same basis, hence both the numbers we can equate it. And then rest of the simplification, it is very clear. And this is the problem, very, very important, a beautiful problem now this is. So we need to solve log of x minus 1 to the base x square minus 3. To the base x square minus 3 greater than or equals to 1. Okay. So my dear children, I already informed you many times and we also solved many more problems of this model. Especially when we are solving about a logarithmic inequalities or a problem related to logarithm, just we need to think about the base. So base should be greater than 1 and base should be lies between 0 to 1, isn't it? So entire this problem now can be solved in two cases. Case 1, when x square minus 3 greater than 1. And case 2, when x square minus 3 lies between 0 to 1. Right? So entire problem can be solved in now two cases. Not only this, every problem you need to solve in the same model. Okay. Now let us see how can we simplify in case 1. So coming to case 1, that is base x square minus 3 greater than 1. So if x square minus 3 greater than 1, when base a is greater than 1, then inequality holds same. No change in the inequality. And moreover, you know here, this is the point you need to observe. 1 I want to mention as log of x square minus 3 to the base x square minus 3. Okay, 1 I want to just mention as log a to the base a. Now because of a is greater than 1, there is no change in the inequality. Hence, x minus 1 greater than or equals to x square minus 3. Right? When this is, since because of x square minus 3 is greater than 1, this is in the place of small a. The meaning of x square minus 3 greater than 1 is nothing but just like a greater than 1. When a is greater than 1, then there is no change in the inequality. That's what log a to the base b is greater than or equals to log c to the base b, then a is greater than or equals to c. This is what? No change in the inequality. So the meaning of this is nothing but x square minus 3 is less than or equals to x minus 1. Isn't it? A greater than or equals to b, nothing but b less than or equals to a. Isn't it? Both are same. So in the same manner, I just want to convert. Now bring this x minus 1 to left side. Then x after comes to here becomes minus x. And minus 1 when it comes here plus 1. Minus 3 plus 1 which is equals to minus 2. So finally we got a quadratic equation, that is x square minus x minus 2 less than or equals to 0. Now as usual we need to go for factorization, and these are the factors, that is x minus 2 into x plus 1 less than or equals to 0. Actually when it is less than, then we write the solution as lies between, isn't it? And along with that less than we have even equality also. Hence the solution is nothing but x belongs to closed interval minus 1 comma 2. The meaning is x is lies between minus 1 comma 2 including minus 1 and 2. Okay. And similarly please simplify this condition also. What is this condition now? Basic condition is, this is the basic condition now, x square minus 3 greater than 1. So 1 if you bring this side, minus 3 and minus 1 becomes now minus 4. So minus 4 I can write it as 2 square. Hence this is in the form of a square minus b square. That I can write it as a plus b into a minus b greater than 0. That is x plus 2 into x minus 2 greater than 0. Then the solution for this inequality is nothing but x belongs to open interval minus infinity comma minus 2 union 2 to infinity. So this is say condition number 1, and this is, you can say it as condition number 2. Now we need to find the common solution for these two cases. I mean these two conditions. Actually these are under the part of case 1. Okay. Now let us see. Try to find out the intersection of these two cases. That is minus infinity to plus infinity. And we need to look at what are the numbers, minus 1, minus 2 and plus 2. So least one is minus 2 followed by minus 1 and then 2. Okay. So now coming to the conditions. Look at me. This is the condition what? Less than minus 2. I think this is the case which is less than minus 2. And 2 to infinity. I think this is the case 2 to infinity. Right? Below minus 2 and above 2 except those values. So these are with open circles. Means minus 2 and plus 2 should not include. Okay. But this is if you come to this equation, I mean this condition lies between minus 1 comma 2. Minus 1 comma 2. This is the thing. Isn't it? So now, do you have any common solution here? So this is the regarding condition number 1 solution. And this is condition number 2 region. So there is no common solution. Hence what we can say, you know, x is equals to simply null set. Null set. I mean no solution at all in this. Very, very important problem. This is a beautiful problem. So there is no common area, there is no common region, hence finally no value of x is satisfying these two conditions, right? Now this is everything comes under only case 1. Now we need to go for case 2. What is the case 2? X square minus 3 lies between 0 to 1. Okay, so when it is 0 to 1, definitely the inequality is going to be changed. So let us see how can we furtherly simplify this. So coming to case 2, that is when x square minus 3, that is base, lies between 0 to 1. So as usual, this one I want to mention as like earlier, log of x square minus 3 to the base x square minus 3. So because it lies between 0 to 1, the inequality gets changed, reversed. I mean x minus 1, not now greater than or equal to, it is going to be changed, no? Less than or equals to x square minus 3. Okay. So because of this condition, when it lies between 0 to 1, now the inequality gets changed, that is x minus 1 less than or equals to x square minus 3. Right? So first let us solve this part. So the meaning of a less than or equals to b is nothing but b less than or equals to b greater than or equals to a. So if I reverse this, hence x square minus 3, then inequality also gets changed, greater than or equals to x minus 1. So bring these terms this side, plus x becomes minus x and minus 1 becomes plus 1. Already there is minus 3 plus 1 which is minus 2. So therefore we got a quadratic in equation, that is x square minus x plus 2. Then go for factorization, which are x minus 2 into x plus 1 greater than or equals to 0. Hence the solution for this inequality greater than or equals to 0 is, here on equating we get 2, but on equating to 0 here we get it minus 1. So this is the least one, no? So hence x belongs to open interval minus infinity comma minus 1 closed, because of equals to we need to close, union closed interval 2 to infinity, closed interval 2 to infinity. Say this is one of the condition. For example, 3. Now come back. What about this one we need to solve now? So what is we have? 0 less than x square minus 3 less than 1. Right now. So now I want to find only x value. Since there is a minus 3, let us add plus 3 on all sides. Adding plus 3 on all sides. Then 0 plus 3, which is 3. After adding here plus 3, minus 3 plus 3 gets cancelled, then remaining only x square, and 1 plus 3, which is nothing but 4. So what we did here, we want only x term. So first constant term we want to remove. Since there is a minus 3, if you add plus 3, it can be cancelled. So adding 3 on all sides, right? Now this is the condition what we got it, 3 less than x square less than 4. So in this, look at the first part. The first part is nothing but 3 less than x square. Means x square is greater than 3. Bring the 3 this side, x square minus 3 greater than 0. Okay, x square minus 3 greater than 0. Now this is factorization, a plus b into a minus b. X plus root 3 into x minus root 3 greater than 0. So what is then the meaning is x is less than minus root 3. And x is greater than plus root 3. So this is one of the condition we got it here. Say suppose condition number 1. And here especially we consider only first part, that is 3 less than x square. Still one more part is left, which is x square less than 4. X square less than 4. Let us solve. Also there is x square less than 4. Bringing this side, 4 becomes now minus 4. Now I want to write it this as a square minus b square as a plus b into a minus b less than 0. Hence x belongs to open interval minus 2 comma 2. This is the one more condition we got now. In case 2 itself, now we have 3 conditions. Condition number 1, condition number 2 and condition number 3. Now let us find out the intersection part of these 3 conditions. Okay. Now look at the first one is what? Less than minus root 3. So this is the part less than minus root 3, which is not included one. And more than root 3. I think this is the part more than root 3 with the pink color. One of the color. Okay. Now let me use one more color. That is condition number 2. Lies between minus 2 comma 2. So minus 2 and this. Let me want to shade it. This is, so even 2 and minus 2 are also not included. Even of course root 3 and minus root 3 are also not included. So that's why everything I just mentioned with open circles. So this is the part now minus 2 to plus 2. So case 1, case 2, now case 3. I mean condition number 1, 2, 3. What is the condition number 3? So condition number 3 is here. Less than minus 1. So in between actually we need to replace minus 1 and here somewhere 1 also. Look at. So less than minus 1. This is the part 1. Less than minus 1. This entirely. And more than 2. This is the part. So do you identify where is the common solution now? All the 3 regions are meeting now. All the 3 regions are meeting at so let me want to explain clearly once again. Look at this. First look at the points ma. So minus 2 plus 2 minus 1 plus 1 even minus root 3 and plus root 3 in their increasing order. So coming to this case, less than minus root 3 and more than root 3. So this is the part less than minus root 3. and more than root 3. Now look at the condition number 2, that is lies between minus 2 comma 2. Lies between minus 2 comma 2. So this is the part, minus 2 comma 2. Already look at here, this is the common region of two intervals, and this is the common region of two intervals, I mean two cases till now. But still there is a third condition also. Finally we want entirely common region. So look at the third one. What is the third point? Less than minus 1. So this is what? Less than minus 1. So hence this is what we are going to get the entire common solution. And one more is 2 to infinity. So look, coming to 2 to infinity, only it is the common part of two regions only, but not the three regions. So finally from this what we got, that x belongs to open interval minus 2 comma minus root 3. Okay, so now this is the solution of entirely case 2. But now we want finally the intersection point of entire solution of case 1 and case 2. So from case 1 and case 2, what is the final solution here? Can you tell me? From case 1 we got actually pi, no solution in the case 1. So therefore I can say that x belongs to minus 2 comma minus root 3 union pi. Do you understand? This is the solution of case 2 and pi is the solution of case 1. Now final solution is case 1 union case 2, that is minus 2 comma minus root 3 union pi. So therefore finally together case 1 and case 2, we can say the solution of x is nothing but open interval minus 2 comma minus root 3. Very beautiful problem. Okay, please go through the explanation of this problem once again, and while writing your notes please solve properly so that you can clearly understand. Beautiful problem here. See, nearly 7 cases are existing here, I mean 7 subintervals. So from that 7 subintervals finally we can get the common solution, that is open interval minus 2 comma minus root 3. Such a beautiful problem. I hope you all understand this. Okay. Coming to the next problem. Find the number of solutions of log of x minus 1 to the base 4, which is equals to log of x minus 3 to the base 2. So please observe here, first one is with base 4 and second one is with base 2. Okay. Okay, first of all let us see. Definitely the bases are 2 and 4, both are positive and greater than 1. Now the given logarithm, the given equality is meaningful. The given equality is meaningful if this is x minus 1 and x minus 3. These both must be positive numbers. So hence I can mention that the given equality is meaningful if x minus 1 greater than 0, x minus 3 greater than 0. So from this we can get it that x is greater than 1 and x should be greater than 3. Isn't it? So this is the one of the condition what we got it. Okay, keep it aside and coming to the problem. This is log a to the base b. Can write it as log a by log b. Hence I can write it that as log of x minus 1 by log 4, which is equals to log of x minus 3 by log 2. Okay. This is nothing but log a by log b, which is log a to the base b. Now in the next step, log 4, I can write it as log 2 square, and that furtherly I can write it as 2 log 2. Log 4 we can write it as 2 log 2, because 4 can write it as 2 square and that power comes to before the logarithm. Now here log 2 and log 2 gets cancelled. Now just if you go for cross multiplication, log of x minus 1 is equals to 2 into log of x minus 3. Now this into 2 I can write it as a power of x minus 3. That is log of x minus 3 whole square. Now this is just like log A is equals to log B with the same base. When there is no base, nothing but we know no base is 10. Right children? When there is no base, the meaning is base is 10. So when bases are equal here, the numbers are also can be equal. So x minus 1 is equals to x minus 3 whole square. Now expand this a minus b whole square, a square minus 2ab plus b square, and these things better send that side, plus x becomes x, minus 1 becomes plus 1, which is equal to 0. Now finally x square minus 6x and minus x minus 7x, 9 plus 1 10, which is equal to 0. Okay, so now x minus 5 into x minus 2 are the factors. So on equating we got it x is equals to 1 is 2 and 1 is 5. Now we have a condition now x should be greater than 1 and greater than 3. Now here which satisfies both. Now if I take suppose x value as a 2, now 2 is not greater than 3 no. So that's why therefore I can choose that x is equals to 5 because x should be greater than 3. So because a number which is greater than 3 is obviously greater than 1. So this condition now no need of consideration. The meaning of x greater than 1 and x greater than 3 together I can take it as a x greater than 3. So in x greater than 3 already this first case is fulfilled. So that's why here the value of x is equals to 5. But coming to the question, number of solutions. So what are the, how many are there now here? The number of solutions are only one value of x, that is 5, isn't it? So therefore the number of solutions is nothing but only 1, and the value of x, what is the solution means, that is 5 is the solution, isn't it? Right, you can also verify using these values. You can substitute in the place of x 5 or with 2 also, then also you can understand which is the right solution. So here finally the solution is 5 and the number of solutions means only one solution. So look at the next one. Find the value of log 2 to the base 3 into log 7 to the base 8 into log 3 to the base 4 into log 6 to the base 7 into log 4 to the base 5. So this is just now we discussed, this entire problem can be solved by using this problem, this formula. Log a to the base b, we can write it as log a by log b, right ma'am? So using this property we can solve this problem very easily. So let us see how can we simplify furtherly. So using this formula I can write it log 2 to the base 3 as log 2 by log 3 into log 7 to the base 8 as log 7 by log 8, log 3 by log 4, even these two also we can write it as log 6 by log 7 into log 4 by log 5. Now log 3 cancel, even log 7 by log 7 cancel, log 4 and log 4 is also cancel. Now let us see what is in the numerator. This is log 2 into log 6 we have entirely divided by log 8. May I write as 3 log 2 ma? Because log 8 I can write it as 2 cube and furtherly 2 cube, then 3 comes here, 3 log 2. And we have already here log 5. Right? So now one of the log 2 is also cancelled. Now what we have? Log 6 by, actually we have 3 into log 5. 3 into log 5. So this is furtherly log 6 by, this is I can write it as log 5 cube. Log 5 cube is 125. And now this is finally, can we mention like log 6 to the base 125? because from the above concept, log a to the base b is nothing but log a by log b. So from this is finally we can simplify it as log 6 to the base 125. Okay. Thank you. That's it for logarithmic inequalities. And in the next video, let us discuss about the exponential inequalities. So from the beginning, we discussed normal general inequalities followed by logarithmic inequalities. And next, from the next video onwards, we will be discussing about exponential inequalities. Thank you. Thank you, students. Thank you for watching.